you can download DeepSeek V4 today. Full weights, MIT license, right on Hugging Face. Good luck fitting it on anything you own unless you've got 128 gigabytes of unified memory sitting around. DeepSeek V4 shipped 2 MOE checkpoints on April 24th, 2026. V4 Pro comes in at 1.6 trillion total parameters, 49B active. V4 Flash sits at 284B total, 13B active. Both live under the verified deepseek-ai org on Hugging Face, MIT license. V4 Pro targets frontier-scale reasoning workloads. V4 Flash trades some of that ceiling for a checkpoint that's actually small enough to talk about running yourself. This preview also shipped without an official pricing page update, so cost isn't part of this video, only the local math. The weights only exist on Hugging Face and ModelScope, DeepSeek's own GitHub hosts code and tooling, never the model itself. Full precision is out of reach for anyone without a data center. Even the quantized builds are brutal. Unsloth's Q4 KS8 XL sits at 105 GB away on disk. Their Q8 KA8 XL at 162 GB. Drop down the ladder and you hit UD Q3 KA8 XL at 129 GB. UD IQ4 DNL at 138 GB. UD IQ2M at 90.9 GB. For scale, that's more disk space than most gaming PCs have total before you've loaded a single token of context. None of that fits inside a normal workstation. The real fix is a community Q2 class build. Teamblobfish's imatrix calibrated GEG UEFF keeps BF16 precision on the critical tensors and pins other layers to Q8, holding the decode speed floor while everything else drops to 2-bit. That's the difference between a plain 2-bit quant and an imatrix calibrated one. The calibration data tells the quantizer which tensors actually matter for output quality, so pinning decisions aren't guesses. Q2-KXL runs about 100 GIB across 3 shards at 23.38 tokens per second on an M3 Ultra. 3 shards just means the download splits across multiple files instead of one enormous blob, nothing more exotic than that. iQ2-XS-XL drops to 81 GIB at 23.73 TS. iQ2's XXS-XL goes to 73 GIB at 23.75 TS, small enough to fit inside a 128 GB unified memory machine with room left for context. A second independent build from antirez weighs in even smaller at 80.8 GB, and its model card says plainly, use Q2 on 128 GB Mac machines. The logic holds. Routed experts make up most of the parameter count, but each one only handles a fraction of tokens, so quantizing them hardest costs the least average quality. On the PC side, an AMD Ryzen AI Max Plus 395 Strix Halo box with 128 GB of LPDDR5X clears the same bar, though not at the same speed. The one real number on that hardware is a rougher IQ1S-XL quant, 58 GB, reporting 1 to 2 tokens per second with occasional repetition loops. Either way, 128 GB reads like the real minimum ticket for this generation of MOE models, not a nice to have. Before downloading 100 GB of anything, run the math yourself. Total parameters times bits per weight divided by 8 gives you the disk size. Plug in V4 Flash's 284B parameters at roughly 2.6 bits per weight, and you land at 73 GB, matching Teamblobfish's real iQ2 XXS-XL build almost exactly. Run the same formula against V4 Pro's 1.6 trillion parameters, and even a 2-bit build lands past 400 GB, which is exactly why nobody's running the Pro checkpoint at home. Before you run anything, check where it came from. Huggingface-cli confirms the repo owner, and deepseek-ai is the only org that matters for the official weights. A verified badge next to deepseek-ai on the org page is the same signal, just in the browser instead of the terminal. That check matters. Within 45 minutes of the April 24th announcement, a fake GitHub org calling itself DeepSeek V4 went up, using the real logo and real benchmark charts. It attached 2 102 MB installer archives to a release. Running them delivered the Vidar info stealer instead of a model. The fake org gathered 91 stars and 27 forks in 4 days. None of that required exploiting DeepSeek's own infrastructure, just squatting a plausible org name fast enough to catch the traffic spike. Here's the actual tell. The only two legitimate places the weights exist are Hugging Face and ModelScope under the verified deepseek-ai org. DeepSeek's own GitHub hosts code and tooling, never weights. A real download also looks different on disk. GGUF shards and safe tensors files, not a .exe or a zipped installer waiting for a double click. I post one of these daily. Subscribe if local AI is your thing. No DeepSeek V4 specific quality study exists yet, since the model's only 3 months old. The closest real numbers come from V3 and R1. Architecturally, the same MOE family DeepSeek V4 descends from. DeepSeek V3 at Q2 KIL scores 61.51 weighted average against 70.5 at FP8, an 8.91% drop, and knowledge-heavy benchmarks take the hardest hit. C-eval falls from 89.60 down to 73.60. That weighted average rolls up multiple benchmark suites into one number, so an 8.91% drop there means every category lost ground, not just one outlier test. V30324, a later checkpoint, drops even further at the same quant, 14.66% off FP8. R1's dynamic UDQ to SHB XL loses just 0.94% accuracy against FP8, playing Q4's KTM only 0.68%. The cliff is specifically 2-bit, not 3 or 4. Treat every number in this section as a proxy, not a verdict, until someone actually benchmarks V4 at Q2 directly. Translate that C-eval gap, and here's what it means day to day. Fact recall tasks degrade hardest. But the model still writes fluent code and holds a conversation. It just gets specific facts wrong more often. A structured JSON extraction task, a specific date, a precise API signature. Those are exactly where a knowledge-heavy quantization drop shows up. Since DeepSeek hasn't shipped small V4 distills, here's the fallback by VRAM tier. An 8GB card fits DeepSeek R1.7B comfortably with room for context. 12 to 16 GB is where DeepSeek R1.14B makes a sense. 32B wants 24 GB or more, and it's tight on a single consumer card. Each of those pulls is a single command, no config file, no manual GGUF wrangling, which is the whole appeal of the R1 distill path over hand-rolling a V4 quant. There's no official Deepseek-ai V4 distill family yet, unlike the R1 generation. Check directly, Ollama's DeepSeek V4 listings show only DeepSeek V4 Pro and DeepSeek V4 Flash, both cloud-routed, full MOE size. What does exist is a third-party distill, Peterogion's Quen 3.5 9B DeepSeek V4 Flash QVAR K-Parm-M Viva 2, a QN 3.5 9B base distilled on V4 outputs, 6.6 GB, 4,117 pulls. Is not DeepSeek's own release, and the listing says so. Ollama lists it with a plain community tag, not a DeepSeek-ai namespace, which is the same verification habit worth carrying over from the malware warning. Third-party distills like this one update faster than official releases too, since there's no internal review cycle to wait on. One more deadline, and it's close. DeepSeek's own docs say deepseek-chat and deepseek-reasoner, the legacy API aliases currently routing to V4 Flash's non-thinking and thinking modes, are fully retired and inaccessible after July 24th, 2026, 15:59 UTC. No grace period is stated after that timestamp. Here's the actual read. DeepSeek V4 Flash benchmarks at 79% on SWE-bench verified and 88.1 on GPQA Diamond at full precision, plus 86.4 on MMLU Pro. V4 Pro pushes to 80.6% on SWE-bench verified and 90.1 on GPQA, against Opus 4.7's 87.6% and GPT 5.5's 93.6%. That gap between Flash and Pro is smaller than the compute gap between running either of them. The bottleneck is that running any of this locally, even at 2-bit, needs a 128 GOI machine, and you're trading real accuracy for that privilege. Quantization is doing the heavy lifting here, not new hardware. Worth remembering next time a run it locally claim shows up. If you've already got a 128 GB Mac or a Strix Halo box, DeepSeek V4 at Q2 is worth the download. If you don't, the honest move is R1 distill on whatever GPU you actually own. DeepSeek V4 is MIT licensed, fully open, and completely out of reach unless you own 128 GB of memory. That's the honest trade-off this generation. Quant links and every command are in the description. New local AI breakdown daily. Subscribe if that's useful.